Hello guys, gals and non-binary pals, hello and welcome to Maths with Skylar. Today we are going to be looking at a thing called standard form. This is what it's known as in the UK. However, you may also see it in the United States. It is also known as scientific notation, and in Sweden we usually know it as Grundpotensform. Now, you will see this in the UK around about GCSE grade 5, and in Sweden you'll probably see this in Grundskolan around about years 8 and 9. So it does make up a part of the stuff which they can test you in the year 9 national tests. So we're going to start off with what is standard form and why do we use it and what are the rules which go with it, which are fairly important. So let's get right to it. So first things first, we're going to look at the rules which make up standard form, because there's a set way in which we need to present standard form. We can't do it in any way whatsoever. But before we get onto that, why do we have standard form? Well, the thing is, standard form is a way of showing very, very big numbers or very, very small numbers in a fairly easy way. And we use powers of 10 to help us do that, because you may recall that 10 squared is the same as 100, 10 to the power of 3 is 1,000, and we can use that to basically teleport to getting like a number and making it really big. Or we could go in the other direction and make the power negative, and we can make it really, really small instead. So that's basically what this does. So we have a special set way in which we do this, and what it is a times 10 to the power of b. So that's our certain way of doing this. Now in this video I will be referring to a as the a value and b as the b value. B value, you can't really go wrong with it. It's kind of tricky to go wrong with it. However, the A value is where you've got to be really careful, especially if you're trying to access slightly higher and more advanced standard form, both in the UK and Sweden. So what we need to know about A is that it is between the values of 1 and 10, but not 10. So we can't have 10, but we can have 9.999999999. That's fine. However, if we have 10, what we need to do is we need to do a special trick, which I'll show you later on, where we turn that 10 into a 1, and it changes our eventual B value. So with B, what B is, let's go for a blue flavour here. B is basically a positive or, very important here, negative integer. Now integer is just a really fancy maths word for whole number. Oops, I've spelt that wrong there. So it's a positive or negative integer. It really is like, this must be a whole number. If you didn't have a whole number, power laws, especially if you do GCSE, you will find that ew, that would be absolutely gross. Ew. In Sweden, we don't really do powers which aren't integers, but if you happen to do VI GCSE, you will be aware of this. But basically, this is what makes our number huge or tiny. That's it. The power of 10-bit, that's what makes our number huge or tiny. So let's go for a few examples here about values which are in standard form and values which are not. So let's go for 7 times 10 to the power of 5. Now, is our A value between 1 and 10 but not 10? Yes. And have we got on that 10 a positive or negative integer as the power? Well, yes, we do. So therefore that one is correct. If we go for something like 5.6 times 10 to the power of minus 3, well, 5.6 is between 1 and 10. We can have a decimal there, no harm whatsoever, as long as it's just between 1 and 10, but not 10. And the power of 10 we've got here is a negative integer. It's a whole number, but it just happens to be negative. So we're dealing with a fairly small value here. So this one is indeed a value which is in standard form. Now if we go for something like 12.3 times 10 to the power of 15, so pretty big. Now the b value here, that is a positive integer, 15 is a whole number, boom. But 12.3, that's not between 1 and 10. And this is where you've got to be really careful when we get onto some of these questions later. You have to fix this. Now I'm going to show you how to fix this, but because of this part here, that means this one is not in standard form. And that's what you need to be very careful about when we get onto the nitty-gritty questions later. But we're going to first go through some examples of converting between ordinary numbers and standard form, and the other way as well. So let's get on to some questions here. These are GCSE format, however, you will see something very similar at around about an E or maybe even a C level in Sweden. So the first question here is write 1.2 times 10 to the power 5 as an ordinary number. Now what this means is basically our answer is going to involve a 1 and a 2 in it. Now what I do is I do a counting rule for this. I basically do a counting rule where I'm counting the first digit, so on the A value doesn't count. So the 1, I'm just going to write that down. But then every other digit is going to count. Now obviously our second digit will be a 2, but then after that, what do we do when we're counting? Because we've only got to count at one digit here and we've got 5. Well, we just put zeros there. Don't forget that 10 to the power of 3 or 10 cubed is 1,000. It's a 1 followed by 1, 2, 3 zeros. So that's what we're going to do here. So the way in which I do it, I basically do it in like a rhythmic style here. And this is how I did it when I did it back in the day, and it worked. It worked absolutely fine. So what we do is we put that down. Oop, come on. Aha, there we go. Right, what we're going to do is we're going to go that and then go 1, 2, 3, 4, 5. There we go. So we've now got 120,000. Now when you're writing it in the answer box, the choice is yours. In the UK, yes, I'm aware that we do write commas, usually between the thousands and the 10,000s. However, I like to just split it up into groups of 3 here. So that's the first question all done. Remember, put the first digit down and then go 1, 2, 3, 4, 5. Why 5? Because there's a 5 there. So 0.003 in standard form. With this one, what we're going to do is I'm going to write the question out again. I'm going to write that value out, 0.003. Now what you'll notice is there is already a place to indicate where the decimal is, the decimal point or comma. Now what we're going to do is we're going to move that comma across to somewhere where it's going to make it between a value of 1 and 10. Now we've discussed 1 and 10 before. That is our A value. So what our A value is going to be. Now in this case we're going to move it here because that will give us just 3. That actually gives you the first part of your answer right there. And then don't forget, we've just got to find out that power of 10. Now how do we find out that power of 10? We think about how many spaces have we jumped from here to here. So 1, 2, 3. That was very squiggly, but it got the job done. That's a 1,000, but the thing is you need to be careful here. Add the negative on. Now the reason why we're putting the negative on is because if we don't put the negative on, then when you're going through and checking your answer, 10 to the power of 3 is 1,000, and we had 3 of them, and that would be 3,000. But no, we don't have 3,000. We've got 3,000ths. Tusendel. So what we need to do is we need to make sure there is a negative there. So what we're going to do now is we are going to put down the next one here, 42,900,000 in standard form. So what I'm going to do is I'm going to write this out again. And this time, let's go for a light blue. Now where is our decimal comma currently? It's right at the end here. We just don't see it, a bit like John Cena. And we need to move it somewhere where we're going to get a value between 1 and 10, which means it's going to move here. So that will give us a new value here of 4.29. So that is your A value all done. Second part here is just how many jumps have we gone? 1, 2, 3, 4, 5, 6, 7. So we've done 7 jumps. So 4.29 times 10 to the power of 7. Okay, so now we're moving on to write 3.61 times 10 to the power minus 3 as an ordinary number. Now we can use what we did here in question 1b to help us out here, because it's basically how many decimal places do we go until we hit a 3, until we hit our A value. Well, here it was minus 3, so we went 1, 2, 3. Boom, there's a 3 there. So in this case, we're going to go to the third decimal place and write a 3 there. So 0 point, now it's automatically going to be 0 point because this is negative. If we see a negative power and we're trying to get it as an ordinary number, we need to write 0 point there. And then we're going to go to 1, 2, 3 decimal places. That's the start of our A value. But don't forget that we've also got this 6 and 1 here. We can't leave that behind, otherwise we've just wrote 3 times 10 to the power minus 3, which is what we got here. So we need to write just on the end that 6 and that 1. And you'll find that the answer is 0.00361. And that's the first set of questions. All done. So we're now moving on to some slightly more difficult questions here. Now these involve using multiplication and multiplying and dividing standard form. So this is multiplying massive numbers by massive numbers, or dividing maybe like a tiny number with an absolutely massive number. Now we can write these out into ordinary numbers. However, that's a lot of zeros to put up with. That's a lot of zeros to combat. And really, this is the kind of thing where it can be made a lot much more easier if you just think back to your power laws, which you would probably have done at an earlier date than before you've reached this video. If not, please do go and watch a video on power laws. So this one here, we're going to first do work out the value of 5 times 10 to the power of 3 multiplied by 6 times 10 to the power of 7. Give your answer in standard form. Oh, those 6 words at the end of the question. I've seen some people really struggle with them, but we're going to get through this in one piece. So, we need to think about, first of all, multiplication. If we're dealing with just a bunch of stuff which we're multiplying together, we can swap it round as much as we like and it doesn't make a difference. There's a reason why 2 times 4 and 4 times 2 are 8, because it doesn't matter what way round they are. So what we can do here is basically group up the A values together. So we'll do just that. And then I'm going to group up all the B values together. So we've got 5 times 6 times 10 to the power of 3 times 10 to the power of 7. And I'm going to put some coloured brackets around them because we are going to keep this nice and clean. So 5 times 6, simple multiplication right here. 5 times 6 is 30. Then we have to do 10 to the power of 3 times 10 to the power of 7. That is, don't forget, if we're multiplying powers together which have the same base value, in this case a 10, we can just add the powers together. So we're effectively doing here 10 to the power of 3 plus 7. So that will give us 10 to the power of 10. Now, this is the massive stumbling block in which I have found a lot of students fall at. It's these 6 mortal words here, which I've just blocked over. Whoops. Give your answer in standard form. This is the part in which you need to be very, very careful about, because you may notice that our A value here, that is not between 1 and 10. It's way over 10. So what can we do? Well, we need to basically balance this out. So what I'm going to do is with the 30, this is what I like to call fixing, I'm going to divide that by 10, because 30 divided by 10 will give me 3. Now, I've made that value 10 times smaller. But the thing is, I need to make sure that my answer is still showing the same thing as what was shown in the original question. So on this side, I need to make this 10 times larger. Or in other words, just multiply it by 10. Now don't forget, multiplying by 10 is just 10 to the power of 1. We just usually don't see it. Again, another John Cena trick in maths. So it's 10 to the power of 10 plus 1. So that's 10 to the power of 11. Multiply those together and that is your answer. 3 times 10 to the power of 11. That a value is between 1 and 10 and our power of 10 is a positive integer. Happy days. Next question here. This one a little bit more tricky. However, that's absolutely fine. 8.69 times 10 to the power of minus 5 divided by 5.5 times 10 to the power of minus 7. So first of all, well, the thing is, division, it works a little bit differently. However, we can, again, just bundle our a values together. So we can do 8.69 divided by 5.5. Now, I will need a calculator for this. You probably will need to as well. However, what you should find is that the value you get is actually quite pleasant. In this case, I've got 1.58, which is lovely. So 1.58, and I'm going to put an equals there just to show that we are doing it the same way. And then we're going to multiply this by 10 to the power of minus 5 divided by 10 to the power of minus 7. Now, we know that there's going to be a power of 10 here, so, well, we know we're going to have a base value of 10. This is where we need to cast our mind back to how division works in power laws. How does a division rule work? Well, what we've got is minus 5, and then because we're dealing with with division, we need to be doing the subtraction of the indices here. But then we've also got minus 7 here. Now, do we like seeing two plus or minus signs together? No, we don't. So we need to think back about our adding and subtracting of negative numbers. So that minus 5, that stays as it is. That's my starting place. But a minus and a minus, they cancel each other out. They give us a plus. And we get a 7. So minus 5 is where we're starting. And we're going up 7. So we get to 2. So it's 1.58 times 10 to the power of 2. Fairly decent value there. Not too bad, 158. Gives us a rather decent answer here. But the thing is, we need to once again check here. Give your answer in standard form. Well, our a value is between 1 and 10. That's awesome. And we also have our b value as a positive integer, which is what we want. So 1.58 times 10 squared is our final answer. Now, division is a bit weird, so we're going to do another further example of this one. So it's work out 3.744 times 10 to the power of 9 divided by 2.4 times 10 to the power of 5. So this one, what we need to do once again is we need to deal with our a values first. Let's do everything in order. So first of all, let me get the pen ready, is we're going to do 3.744 divided by 2.4. Now, I've already done this earlier, True Blue Peter style. It was 1.56, which is a lovely value here. At this step, you should be seeing nothing more than about 3 decimal places. If not, you may need to do a bit of sensible rounding, should say in the question. If not, I would go back and have a good look at it again. And then what we're going to do is we're going to deal with our powers of 10 to get our b value. So in this case, 10 to the power of 9 divided by 10 to the power of 5. Cast your mind back to power laws. What we're doing here is we're starting with our 9, taking away 5. 9 minus 5, that's lovely. That's just a 4. So it's 10 to the power of 4. And that is the final answer for this part here. Ooh. For our last set of questions here, we're actually going to do some here in Swedish, just so that, well, any of you who do happen to study Swedish, you get familiarity of how tricky this can get. So we're going to start with question 27 here. So I'm going to put 27 right there. We've got one red blood cell is equal to 7 times 10 to the power of minus 6 meters in diameter. In 1 milliliter of blood, there is roughly 4 times 10 to the power of 9 red blood cells. If somebody were to lay out all the red blood cells from a single milliliter of blood in a long row, like next to each other, how long would that line be? Respond, give your answer in standard form. Classic 6 words there, so be very careful about it. Well, what we're doing is we've got the length of one red blood cell, and we've got how many red blood cells there are in a milliliter of blood. So that's great, we don't need to do any converting before doing this. So we're going to do 7 times 10 to the power of minus 6. So that's the length of one blood cell, and we're going to be multiplying that by how many red blood cells we have in 1 milliliter of blood, which is 4 times 10 to the power of 9. There we go. So what we need to do now is we're dealing with multiplication here. That was the length of one red blood cell, and that is the number of red blood cells we have. So what we're going to do is we're going to collect all of our A values together. So I'm going to do 7 times 4 first of all, and then I'm going to do 10 to the power of minus 6 multiplied by 10 to the power of 9 later. So that 7 times 4 will give me my A value, and the 10 to the power of minus 6 times 10 to the power of 9, that will give me my B value. So 7 times 4, well, that's 28, and 10 to the power minus 6 multiplied by 10 to the power 9, well, what we're doing here is it's our multiplication power law we're doing, so it's addition. Start at minus 6, go up 9. So we get to 3. There we go. Now, we need to check here. There is a very important keyword here, and that is respond in, give your answer in standard form. Now, if we do our little check here, the B value's fine, but our A value, that's not between 1 and 10. That's nowhere near. So what we need to do is we need to fix it. Now, in this case, we're just going to divide by 10, because that'll get it to 2.8, and that is absolutely fine. Sometimes you may need to divide by 10 squared, however, this case, not really. So we've made the left-hand side 10 times smaller, but we need to make the right-hand side 10 times bigger. And don't forget that 10 is just 10 to the power 1. So that is going to be 10 to the power of 4. So that is how long it will be. And in this case, what we need to do now is we need to respond in our units here, and that was meters. So it's fairly long. You're quite surprised here about how long it is. And that is our final answer for question 27. So let's now move on to question 28. In the world seas, there is roughly 5 times 10 to the power 19 kilograms of salt. The world seas have around about 1.3 times 10 to the power 21 litres of water. How many kilograms of salt per litre are contained in the in ocean waters roughly? Again, obviously, it's just about roughly an approximation. Can't be exactly right with this kind of stuff. So what we're going to do here is we are going to, first of all, well, we've got a lovely thing here. We've got kilograms of salt per litre. Now, if we ever see the word per, we need to be thinking of division. So what we're going to have is we're going to have basically kilograms divided by litres in our equation here. Now, have we got something in kilograms in standard form? Yes. And have we got something in litres in standard form? Yes, we do. It's right here. So what we're going to do is we're just going to put those in right away. So 5 times 10 to the power of 19, boy, that's a big number, divided by 1.3 times 10 to the power of 21. Goodness. So what we need to do is let's deal first of all with our A values. Now we need to do 5 divided by 1.3. Now that's going to give you a fairly nasty value here. Now, fairly nasty values, they are expected, we can't get away from them. And so what we're basically going to do is we're going to basically do a little bit of sensible rounding here. Now the answer I got was 3.84615384615. Ew. But I'm going to just round it to the nearest 2 decimal places. So 3.8 and then that 4 will look right to the 6, that goes up. So we'll make that 3.85. And then what we do is we get our power of 10 here, and then division rule of power laws here, 19 minus 21. That will give me minus 2. And then we just need to be aware of how many, basically what is our unit of measure here, and that is kilograms. And that is our final answer for this last section here. Ooh. And finally, 3 key points just to finish things up here, just so that you are aware of, and basically these are the 3 main points which you need to know about tackling standard form. First of all, know your A and B value rules. Basically understand that with standard form we are always dealing with powers of 10. We're not going to see an 8 there, we're not going to see a 4 to the power of bleh there. We're never going to see that. It's going to be 10 to the power of something. And don't forget as well, the value which precedes it as well, the A value, has to be between 1 and 10, but not 10. The second thing is know your multiplication and division power laws here. Remember, multiplication of values with the same base number is just a bit of addition. And division is only if you have the same base number, we do a little bit of subtraction. Now, do not get this mixed up with simple addition and subtraction. What you learnt back in your early years of school does not change. This is only for when we're dealing with powers. So 6 plus 4 is still 10. 7 minus 2 is still 5. And point 3 here, beware of the A value not being between 1 and 10. I have seen this many times when marking assessments, that people will be fine with the standard conversion thing of converting a normal number into standard form and standard form into a normal number. They will be fine with putting it in standard form. However, if we start to get anything about applying, just like those later examples which I've shown you, you've got to be very careful about this, because otherwise you are violating the law of standard form. So that is all on standard form. If you are still a little bit stuck with this, I would certainly advise looking at videos about calculating with negative numbers, as well as your power laws as well, specifically for ones regarding multiplication and division. So that is all for today. Have a nice day, and don't forget to comment, like and subscribe. Thanks very much for watching. Just to let you know, I do have a Patreon, Ko-fi and Twitch account where you can donate to as much or as little as you like, and some subscriptions with some little rewards on top of them. Just add Skytree95 in the search. Thanks for watching, I'll see you around.